Okay, I guess we're starting. Everyone can hear me okay, hopefully? Yeah? Everyone can see my fabulous outfit okay, right?
Yes.
Super. Everyone have a good first day of NolaCon? Yeah? Super. Okay, so this talk is largely about what happens and what you're going to do after you get shell on a Mac endpoint. So this talk is brought to you by Black Sun Hackers Club in joint production with Proper Villains. That is all the bio you will get. So a little bit of disclaimers, updates, and circumstances. So disclaimer one, just because I get asked like over and over and over and over about that meat pistol thing and the moist pedal thing, I'm just going to like take a quick second to kind of like set the ground here. This talk's not going to be about that, obviously. It's probably not going to get open source. So sorry. Yeah, it's a bummer. Like when all that stuff happened, I was sort of like fired and then not fired and then in negotiations with lawyers and stuff, and they basically wanted to give me like about over 100 grand for like hush money, and I sort of turned my back on that trying to get the tool open sourced and like being like, we should really open source it, this is going to be bad. But like once things get buried in legal processes, they don't really like ever come out. So my ability to actually open source it is not really any now, because if I do anything, I'm pretty sure that I will have a full force of terrible things happen to me. That said, there is work on a new tool. I know some of you have watched the like moist pedal repo. There is work being done that will get updated. There is something happening, but it's going to be some time, I think. So that said, about my like previous employer, you know, they're not that bad. Like people make mistakes. I know everyone loves to hate on them, but like so like a lot of the stuff I'm talking about, like I learned like being on an awesome red team there, right? So like just people's appetite for getting owned really hard and having like an awesome red team pushing their shit in all the time, maybe it runs out after time. But good news is I did get a new job. Thank you for asking. I am over at Oath now, directing the offensive security program there, building out a red team. I am here in no way representing them at all. This talk is way before I even took the job there. Nothing I say here reflects their views or opinions, etc., etc. This is just FuzzyNop. Josh dances on stage and talks about Mac stuff. Also, some good news and some bad news, some unfortunate circumstances. I was supposed to have a co-presenter here today. He had a family emergency, and I wasn't even able to get a hold of him for a few days. But good news is he did most of the research for this like months ago, so we have all that stuff. I think the flood is coming. Is it the end of days or? Okay, well we better make this count. Okay, so I will try my best to present the research as good as possible, and I think because he's not here, I'll probably just tell more stories about myself because I get to do that because it's just me here now.
Yeah, you can't move. Sorry.
I'm not trying. Oh, I like to move. Okay. So here's a bit of the agenda. We're like, bam, you got shell on Mac. Talk about how we get to this point or how this even happened. Kind of like what you're going to do when you're like, man, I should start stealing some things. Ways you might have some persistence in keeping that. Ways you can get root. Things you can do with root. And then if we have time, I will show you a really easy 2FA bypass. So how did I get here? It's a pretty straight, I mean, really, like, how did I get here? Long time ago, I was working at an incident response company, and they were largely regarded as, I think, the best IR company you'd call them when your stuff was getting messed up by China or so. And so they had a lot of customers, and then I worked in the small office out in San Francisco, and we started getting some of the customers there, and they would want pen tests because, you know, everyone sort of makes the mistake that, like, if you're good at something, you must be good at everything, right? So because they were good at IR, people were starting to buy pen tests from them, which didn't make sense. I started to get some of these pen test jobs assigned to me because I was good at CTF, I guess, and they were like, you can do it. So the very first one I ever did, I go on site, and it's this like biotech startup, and they like sequence DNA or something like that. And I'm supposed to show up on site. And I'm supposed to do a Wi-Fi scan and like a network scan. So I'm like, okay. Like I show up. I think I like download Nessus while I'm there, and I'm like starting some scans. And I'm thinking like, what am I even doing here? And I'm also thinking like, Wi-Fi scan, like, what do they even mean by that? Like, am I scanning for Wi-Fi networks? Am I supposed to scan what is available on the internal Wi-Fi? And I'm like, I did that. It's been about 15 minutes. Like, maybe I should go talk to the CISO here. So I go talk to the CISO. Super cool guy. He's really excited to tell me about how awesome security stuff is. He's really proud of it. And we get to the point where, like, we're talking back and forth, and I asked him, like, oh, like, do you do internal scanning? And he's like, yes, we do credentialed Nessus scanning, like, every day on internal and external. And then, like, probably being, like, the worst consultant on site ever, I'm like, why did you even pay for me to come here and do this? And he's like, they sold me some stuff and we bought it. And so I was like, that sucks. Like, I'm not going to find anything that you don't already know about. So we start talking more, and he starts complaining about, like, there's MongoDBs and these guys do this other stuff. And I'm like, hey, why don't we open up the scope? Like, let's change the scope. I mean, you're the one who bought it. Like, you can approve that. Let's change the scope, and, like, let me do social engineering. Like, let me fish people. Let me try and get to this stuff that you actually care about. And he's like, yeah, cool, do it. But then he's like, but, you know, we have 2FA on stuff, so you, like, probably won't be able to get into anything. So I'm like, okay, cool, it's on. Set up a phishing page, pick a few targets, phish them, I get their creds, I go to log in, as he said, 2FA. It sends this sweet old lady an SMS to her phone, and back then it wasn't like super clear, you just get like SMS with some numbers. I'm like, crap, okay. Well, I guess I'll just keep doing that. Just keep logging in, like once per hour for the remainder of the day. And then towards the end of the day, give her a call. I'm like, hey, this is Andrew from Google Authentication Response Services. Have you noticed anything strange happening today? She, of course, is like, yeah, I'm like getting all these weird messages like, oh, yeah, that's a problem we have right now. Your cryptographic synchronization token is out of sync. And I can sync it. There's going to be a long-term fix, but I'm part of a special task force that's going around and responding to this, and I can fix it for you today if you want, and then you won't get any more of these messages. And she's like, oh, yeah, okay. And I'm like, sure. So I'm just going to have to send you a reset code, and you're just going to tell me that code back, okay? Log in again, code. She tells me the code, and I'm logged in. And then once you're logged in, of course, it's like a flat network, and you can just run train on it. And I was able to get to all those things. So from that moment, I was pretty much addicted to like the YOLO scope mentality, where I was like, there's no way I can go back to just going to doing scanning and stuff like that. So as that was like my job getting sent out to do that stuff, I didn't stay at that company very much longer, and then I went off to the next journey, which ended spectacularly, as you all remember. but it was a great ride. The next journey was just like red team stuff. And now that startup that I was pen testing was like probably like 80% Mac endpoints, and the rest was like Linux stuff. Maybe there was one or two Windows boxes. And then the next thing, like, you know, a company that shall not be named, also like tons and tons and tons of Macs everywhere. So first day on the job, they're like, go get shell, go hack prod, go do something. Well, I'm like, okay, so write some malware, start phishing people, and I'm winding up with a shell on Macs again. And I'm like, I don't really know what I'm doing here. So time to figure it out. So I'm like, probably better steal something, I guess. So let's talk about some post-exploitation 101, right? Of course, like, there's lots of good post-exploitation cheat sheets out there. You can do all that stuff. I mean, there's lots of things you can look for. Here's just a quick few of the things that, like, right when I get on the box, I'm like, okay, this is what I should look for. First, bash history. Well, before I go looking for their bash history, I unset mine because I don't want them, like, bash history is really, really good for you to see what the user's doing, but it's also good for the people to see what you're doing too, so unset the bash history. You don't want to leave a stupid trail like that behind. Now, I think most people think, like, what are you going to find in bash history? Passwords? Yeah? Sometimes. Yeah, I've seen it once or twice. Someone fat fingers their password and it goes into the bash history because they didn't type sudo first or something like that.
Or passed it on command line.
Yeah, or pass it on a command line. So you can search for like -p and see if someone's trying to pass it through. For the most part, bash history though, it's like you should just read it. Like just scroll through because it gives you context of what that person does on the system, right? It teaches you about them. And I normally search for like SSH in bash history. So like, does this person move to other boxes? Because if I phish someone, getting onto their machine is hardly ever like my end goal, right? My end goal is far away, so I need to know how to get to other places. So seeing SSH in their bash history is like way better because I'm like, if they've went there before, they'll probably go there again. That's going to be useful for me later. Also, just looking at hidden files, do a quick find. Just look for any hidden files in the system. They're typically hidden for a reason. You'll find AWS creds there. You'll find tons of stuff. I mean, you guys know that. Environment variables, I don't understand why exactly that like at some point everyone was like, we can't have passwords in scripts, so let's use the environment variables, aka like some secure enclave, right? There's only one password that unlocks it. It's ENV when you type it on the system. I don't know, but for some reason there's tons of stuff there. Typically looking at output of PS, again looking for like SSH connections. Also looking for any type of little script that's running. If there's any script and not like a program that's running, and you're just like, okay, cool, any scripts that are running, I'm going to go look for them scripts on disk. If I can write to them, especially if they're running in the context of a different user, like really, really quick and easy escalation technique. Probably want to see who else is logged onto the box. Might be useful. Really important, I want to see who continues to log into the box remotely. So running the last command to get a list of who's logged in before. If I see that regularly there's some super admin account or a service account that logs into the box, suddenly maybe like my next tactic is like, well, if I get root, I'm going to put a PAM module on this box. And I'm going to wait for that thing to come by and log in again. I'm going to take that password and suddenly I have lateral movement everywhere. So those are like basic post-exploitation stuff. The clipboard, for some reason, is also a secure enclave for passwords, mostly because just of the way password managers work. They make you a really, really long password string that you could never type or never remember. Thank you. And then in order for you to use it, they copy it up into the clipboard and then paste it back in. So here's two different ways to do it. One bash. I think you wrote that actually. So sorry to share your super secrets here. But essentially all we're doing is like using the pb paste command, by the way, built into OSX to dump the contents of the clipboard. Anytime that changes, well, let's log it down to a file. That way I can like start running this, wait till the next day, see some context of what they've been doing, what they're copying and pasting. Hopefully it's not like love letters or Craigslist personal ads. Oh wait, those don't exist anymore. Or what?
On Linux it'll be
Xclip on Linux. Cool. But yeah, password's probably going to be there. So neat. Thanks for OSX for building in that tool. So at a certain point, kind of depends on how you got shown, what kind of malware you're using. The quality of most malware out there is a little bit lacking. There's a void where a really good framework could probably be out there and raise that quality, but rip, yeah. But you probably are like, man, I want to keep this shell. So you need to have some type of persistence. And you have like old Linux style persistence, cron, that's built into OSX as well. So you could go and edit the cron tab and say like every minute I want my malware to run and make sure it's on the system. Or you could say like, well, it's going to sit in memory until like the system reboots, but then when it reboots, I want it to run again, right? So that it can be persistent. Most incident responders will check cron. It's sort of like 101 stuff for them, but it is a thing that you can use. There's actually quite a few options on OSX that you're going to have. You have etc rc common, which is like login items. Like whenever the system starts up, and the user logs in, all this stuff is going to get run. So if you put some commands in there, they're going to get run. However, editing that requires root. So you also have system library startup items. Editing this also requires root. You also have library preferences by host. What this is, excuse me. This is the reopen item. So you know how on OSX when you're I'm going to restart, and it's I want all the windows to reopen again. So if you put stuff in here, when that reopen function gets called, it will pull your malware up too and run that again. So it's kind of a neat persistence mechanism. However, you probably need some other type of watcher process there because these files get clobbered pretty regularly. So if you put it in one of the files and someone goes to restart and they click reopen Windows and login, it might overwrite the stuff that you put in there. So it's not super reliable, but it does work. And then the list kind of goes on, and there's special cases for them. However, LaunchD is sort of like your best framework for persistent stuff. Unfortunately, like many people know about this too, but if you want malware to like stay on the system, and this is meant for, it's an open source scripting engine using XML that allows you to basically identify under what conditions and what should run. And then the conditions actually are pretty robust. You can do a lot of things. The best and most obvious one, like the classic example, is you are going to be like keep alive. So here, let me pull this up. So yeah, you guys can see that maybe? Yeah. So you're basically giving it like label, which is what you're going to see as the thing that's registered when it's running. When if you run like launch, so like launch CTL is the command that does this. That's how you interact with it. The label is going to register. Program is what is going to get run. So for a few of these demos, I think like people aren't popping calculator on systems as often enough. So I've wrote this exploit here to run calculator. So our malware will be calculator. So we'll demo this. Run at load means start up anytime I load the module. So that way you can use this to also launch the malware as well. You don't need to include that. Keep alive, basically this tells the operating system that like no matter what, keep this thing running, which is pretty useful for your malware. So let me let's take a look at this in action. So we'll do, probably can't see that, huh? Isn't that better? We'll do launch oh again, I can't type today. Launch CTL. Okay.
I don't need like a tectonic wall.
I noticed that if I hit my foot against the ground like this, that happens. So I'm going to try not to do that anymore. Okay. So this one, let's take a look at our classic plist. So we're loading that, and boom, it launches it at load. Calculator's popped up. I'm going to be like, I don't want calculator to be running. And the operating system is going to be like, no, calculator needs to stay running. It's really important that calculator stays running all the time. So I guess you could prank someone with this, and that'd be quite annoying. So maybe I can unload it before calculator pops up again. Almost. Okay. Oh yeah. All right, we got it. So other than this keep alive, so this is like your basic thing, right? If you throw this on a system, like malware is going to stay on it. So I thought we could have a couple more creative ways to use it because it is really flexible. So rather than just having like this thing that's like, hey, keep it running no matter what, maybe we want like a dropper script or some kind of thing to happen like at sort of random intervals. And instead of coding in random intervals and letting it like sleep all the time, we can just have a launch agent watch a directory. And then when something changes in that directory, say like anytime a user downloads a file or anytime something gets hit in temp, maybe, then we're going to launch the malware. So this looks like this. Launch on dear change. And actually, let me show you the code here.
I'm not supposed to tell you, man.
Okay. Sorry, guys. All right. So this one is like this. So what we're saying here is like we're giving it a watch path, and watch path says if you give it a path, it will watch everything inside that path, and anytime something changes or is modified inside that directory, it will run whatever you want it to run. So we're running, our calculator exploit here, the most malicious of malware, and it's also going to run at load. Oh well. Or no, I think I took that out alone. Okay, so now we have it watching the downloads folder. I'm going to go to Chrome and I don't know. Dane Cook. Let's find a picture of Dane Cook and download it. Hopefully this works. Oh. So you can also see like if I'm like, oh shit, I didn't mean to download a picture of Dane Cook on my computer. I didn't want that. Seems to be running like anytime something changes there, so that's good. Yep. If I'm like, you get out of here, Dane Cook. Oop, okay. Right, so that's like pretty decent persistence mechanism where like something is going to keep running, but it's based on user behavior. So this can be useful later where you're like, I know that like the user, well, it's a little overzealous. Remember how good it was? This is the best sound ever in here. All right. So I should probably unload that, otherwise it's gonna calculator's gonna keep popping up. This is like hard mode. I'm doing a whole lot of stuff up here. Okay. Another thing I thought might be interesting is if you want to have a system and you want to infect it, but you don't want the malware to run at all until you maybe trigger it remotely later. So we could do something like add a socket listener, which is going to look like this. In here we are saying, okay, this is the program we're going to run, calculator exploit. We're going to have sockets and listeners, and we're going to let it listen on localhost for anybody to talk to it. And if someone hits port 31337, then it's going to suddenly launch. And this is launch on socket. So no calculator. I'm just going to do it to myself here. Boom. Okay, so this could be triggered remotely too as well. So you can imagine you like infect a whole bunch of systems with this, but you don't want every box in the environment shelling out all at once. But you want like some ability later to be like, oh, this system, I want to shell. Okay, I'm just going to like netcat one port and it's going to shell out to my C2. So some other creative ways to use it when you're in an environment.
What happens under the hood when you start this service? Does it actually start like a listener on that port?
It doesn't.
Nice.
So while that runs, this won't come back with anything. There is no listener listening. It's just looking for when something like tries to hit that port, whether or not it's open. So you could do it to an open port, I think. Actually, I should probably check that, but okay. Let's move on. Okay, so yeah, we have malware, yeah, we have persistence, but let's go back to this thing where like we have a shell on a Mac, and there's not a whole lot we can do without root, right? I mean, there's a whole bunch of cool stuff we can do root, but the way Macs are mostly set up is that the local user is going to have root on their system. So I talked about this. I just want to let you guys know. I talked about this same technique 4 years ago, okay? And this general technique 4 years ago still works, and I've never been caught. Like it came out of a moment of desperation where I was on a test, had a shell on a Mac, couldn't find the user's password anywhere. None of the keyloggers work in user land. I can't be root because I don't know their password. I'm just frustrated. I'm like banging my head for a week. I can't get off the system. And like I go to my boss. I'm like, I think I can use this thing to just like prompt them for their password and like make a fake prompt. And my boss at the time says like, that will never work. They will report you immediately. That's so crazy. So I like didn't do it for another couple days. I'm just like, I'm desperate. I'm going to do it, and we'll see what happens. And I like throw up the box on them, and they instantly type their password. Since then, I have never gotten caught by doing this, and it works basically 100% of the time as long as the user is there to type their password in. So since I first talked about this years ago, I've gotten a little bit better at this. Originally, I thought you had to make a specific application do this, but there is a like grand like UI thing called system events that's available. So you can send messages to that, and it will pop up on top of everything. The code that I released got included in Empire, so if you ever are using Empire, there is a module for this. So that should probably get updated because this is way better. Because before you had to like open some application and like bring it to the front of the screen, but this you can use system events and it just pops up on top of everything. So the general way it's built is there is a built-in method in AppleScript, and you can run it with OSAScript-E, and you just type in AppleScript. But this can run any kind of scripting, OSA scripting language. But if you tell it display dialog, it kind of gives you a base set of things already. And if you just say like the dialog is give me your password, you have like a dialog that will pop up, and there's a cancel button and an OK button. So you like start building from there. You probably need them to have a place to type their password in. So if you use default answer as well in this command, they will have a place to type their password. But passwords being typed in clear text, kind of garbage, right? So if you then also say with hidden answer, it hides the password. Now we're looking a little bit more legitimate. So let me show you something interesting here. But I didn't know this 4 years ago, but I do now. If I do this, I get this pop-up, right? If I'm like most users, I'm like, I don't want pop-ups, escape button, and it goes away, right? So I don't really like that that can happen, and I don't like that there's an option to cancel here at all. So if we do with text buttons OK, meaning the only button is OK, and the default button is 1, if you don't use default button 1, when they hit enter, it won't submit, so that's what that's for. But if you do that, oops, got an extra. If you do that, that's me hitting the escape button and getting a system bell. It's like, you can't escape me. There's no cancel button. You can't escape. And so, and actually, people asked me a couple days ago if like you could kill this from system preferences or kill the process, and I couldn't find an easy way to do that as well. So your lame user is going to be like, their only option is to try and hit enter without typing their password, which makes it go away. But if you come back here and you see that there's no text returned, guess what your move is? Hey man, you didn't type your password. Get back up there, right? So when they type their password, this comes back down to here. Oh man, I shouldn't have typed my real password into there. Sad lock cause, that's what it's called. Okay. So still doesn't look very legitimate. You can add a title. So you can say the title is software update, something like that. You can add an icon file. And this is where it gets really interesting because you can sort of add an icon file from anything. In the old method, if you were pointing towards an application, it would automatically take that app's icon, but you can point it towards any application's icon. And it's going to be like, because Mac, like applications.app, they're basically a folder with things inside of them. So you can go under like contents, resources, and the icon file will be in there. So you go grab it from any application on the system you want. Here's a couple for your use. That is too small to see, but maybe you'll be able to see it later. There's software update, file vault, iCloud could make for some interesting ones. If at the bottom there you can see, if you want to just search for icon files, do find .-iname *.icns, which is the icon file format, and just like let it search the system for icon files, and you'll have a big list of things that you can use and pick and choose from. One thing I've noticed is this whole like OSXscript thing isn't just a tool for like doing evil deeds. Lots of like fleet endpoint management people will use it when they're like, oh, I need to prompt everybody in the environment for their password to update it on the back end or something like that. So they'll make their own OSXscript prompts. And maybe for some other reasons, they may put the company logo icon file on the system. So if you wanted, you could probably grab the company's logo and create some kind of pop-up dialog as the company too. Just a thought. So you end up getting something like this, which like, it's not bad. I mean, it's okay. It's been around for a while. For some reason, it still works. So my hope here is by telling you all this again, more and more of you will use this on engagements and maybe like internally at your company, and then like slowly it won't work anymore, right? Because it's been a while. Like people shouldn't fall for this anymore, but they do. So yeah, this isn't bad, So we've got this. You can probably trigger this automatically from Empire now. So, but it's not perfect, right? Because like real prompts, they look like this, They have two text fields. One has the username. They've got bold text at the top and then a subtext. There's a big lock icon. So like, we kind of knew that it wasn't perfect. So shout out to my co-presenter who wasn't here. He's like, okay, I got this. Here's a fake one. Also using OSXscript. Here's the source code for the background. So see, that's just in case something doesn't get open sourced, you guys can fine-tooth comb that and recreate it. No. So here's how this works. So the script is basically using the Cocoa framework, and it is just drawing all these elements. So like when you use AppleScript and you're like, hey, like display dialog, it like automatically creates a bunch of this stuff for you. But you can call the underlying subsystems and draw stuff in an accessory view and just put whatever you want in there. So he's basically making an overlay to get this lock icon and put another icon on top of it so it looks legitimate. And then everything else is just manually drawing the window. So this is what this looks like. My computer's a little old, so it barfs for a second.
Report.
Okay. I've tested this about 70 times. First time that's happened. I'm going to laugh if it doesn't work again. Okay, there we go. Okay, so here is our fake guy. Pretty cool. For comparison, here is the one we are copying right now. It's this. It's the prompt that happens when you try and do this. Click on lock to make changes. So real one, fake one. Real one, fake one. Slightly different, right? Tiny differences. You know, it's kind of hard to see. I'm trying to zoom in on my screen. It's not working. But pretty good, right? Pretty slick. Yeah, I think so too. So thanks. Okay, so I was thinking maybe I could. So like, if that thing just pops up, you know, still having the like my boss's words echo in my head for all eternity, like that's never going to work. You're going to get caught instantly. I was thinking like, okay, it's weird if that pops up out of the blue. So I was thinking maybe we can combine these two techniques so that when the user does something, they get this prompt. That way it's sort of like more normal operating system type of thing. So I had an idea that, so like we have this Keychain access app, which we'll talk about this a little bit more. But most applications will store secrets in here. So like when you install stuff, like things change in here pretty regularly. And this is something that like typically is important. So perhaps they are getting these pop-ups where like you have to click allow for certain things. So like sliding our pop-up in at the same time would be good. So the idea was, let's do a watch path on the keychain itself. So let's watch for the keychain file to change, and then let's trigger our OSA prompt. Does that make sense? Yeah. So this guy, launch DTL, load, and this is OSA on view. So now this is going to watch for the keychain file to change, and I'm going to like this would happen. This happens pretty frequently. Actually, let me see if I can do this. Let me launch Slack, which I think does a read of the keychain, and Slack is popping up. Maybe my thing will pop up too. I didn't test it like this. Maybe that's not significant. So if something got added to the keychain brand new, oh no, there it is. It's just too slow. I've lost it. You guys all saw it though. It was there. It's legit. I should play more first-person shooters then, huh? So here we go. So like I launched Slack, and system preferences is now trying to unlock security. So I could change. I mean, remember, like we're drawing whatever we want on here. So we could make it like, okay, we're going to target Slack specifically, or we're going to target the keychain. So when the keychain changes, our OSA script prompt pops up.
Is there a way for you to figure out when they successfully put their password in, and then pop it up again so it looks like it's...
Yeah, you could. So you could take this and you could wrap it in a script, and then you could like, so whatever I type in here, real passwords, okay, is then going to be logged out to, shit, I forget where I logged it. Big prompt not logged, yeah. So passwords are going to be logged here. So you could have another script that's like watching this and is like hey, I got a password. Like, is it right? Like, does it work for me to sudo on a system? If that fails, then like prompt again. Chances are, so when like in the past, when I've used like the manual little OSO script thing, when I prompt people, even if they type their password in right away, sometimes I'll just prompt them again to see if they'll type in a slightly different password. Because maybe they have like a password for their system and a password for SSO, and they like get them mixed up all the time. So I'm like, and if I can get like, maybe it's like old password and new password, and they type both, that sort of gives me the idea of like, okay, this is how they change their password over iterations, and like maybe I'll be able to guess all passwords then from the future. So,
is there a way to get a read on what application is triggering the keychain access from your plist or your so like for example, if you go to, right, and then all of a sudden like security and privacy preferences wants to unlock your keychain or needs your password, like if you could get a read and say like Slack requires keychain access or something like that.
Right.
Like the Slack icon.
Yeah, so I think the combination of these two techniques, being able to watch any file on the system for changes, and then being able to trigger like a prompt coming up, you could then be like, okay, like, I mean, it becomes an exercise of going to find the right file to watch, right? So like, if I want to target Slack specifically, or maybe I want to target like a password manager specifically, I'll be like, okay, I'm going to, I'll show you something actually in the next couple slides, but it's like, I want to figure out what files that thing touches when it starts up, and I just want to watch like one of those files that never gets touched any other time. That way, like, and then my prompt will be like specifically drawn for that application, right? So maybe it's like 1Password, and I want to do an extra 1Password prompt, but I'll wait for them to launch 1Password. That way, it's not just like hacker randomly doing something on the box, but it's user does something, system prompts them again.
So my question then is, if you're going to like start enumerating all of these target apps to watch for changes, can you combine those watches into one plist, or do you need a separate plist for each thing that you're going to watch?
I haven't tried combining them into a bunch of plists. I think each one only takes one program argument, but it is XML, so see, you know, my co-presenter would have been able to answer that question. Rip. Okay, so now we have this like cool technique in like in the vein of like maybe we want to find other things, but we also have like access to the keychain now. Like if we have their password, the keychain application is basically like a password vault for all things like on the system, right? So the user's password unlocks it though. So now you have the user's password, you can just grab their keychain. You can type in security list keychains, it will tell you where they are. The default location's in the user's home folder under library keychains, login.keychaindb. Don't try and mess with their keychain on their system. You can use a security command to like try and query it and stuff like that, but it causes like crazy mad pop-ups like, malware is trying to access your keychain. You have access to the file because you're the user. You just take it off their system. You can either throw it on another Mac system, or there's a tool called Chainbreaker that runs on Linux that you can use to query it and get stuff out of it. So, what's inside Keychain, might you ask? First, Chrome Safe Storage Key, which is where all the Chrome cookies are encrypted with. There's also application secrets, which I'm going to show you a nice trick with. Safari, by default, saves all their passwords into there. Wi-Fi passwords get saved into the system keychain. If you add SSH keys to your SSH agent on OSX, like they get saved in there. Certificates are saved in there. The list goes on. There's a whole bunch of stuff in there. Might be good to like take a look at your keychain and see what's inside there. So, how about stealing application state? So, you ever notice like there's some applications that basically like once you sign into them, it doesn't matter if you restart your computer. It doesn't matter if it goes like anything happens. You basically like start it up again and it is forever signed in. Slack being a good example, since a lot of people use that. But this general approach will work for anything that works like that. So step one would be like notice that this thing is in the keychain in the first place. So I'm like, ooh, I see. Slack is saving something in the keychain. Step two is be like, okay, I want to see what it's saving particularly. Like maybe it's just clear text passwords in there that I can now decrypt. It's not. Inside mine, there's this thing that says top 5 NM gut. I'm like, okay, whatever that is. I think that's something that's related to my username. I was stuck on figuring out how to get this to work for like weeks and weeks because I didn't realize that the output here, where it's like show password, can be multi-line. And if you press down, there's like 7 lines of stuff underneath that. So I was like manually copying over this value, typing in like top 5 nmgut into like another thing, and it's like not working. And I'm like, oh, what's the problem? So I figured this out today, actually. So then step 3 would be like, okay, you'd be like, I have the user's keychain. I see that they're saving this application secret in there. Okay, like I'm just going to go get the application and install it on my computer as well. And then I'm just going to take those values, I'm just going to copy them from their keychain into my keychain and see what happens, like launch the app again. If you do this, it fails. It fails pretty spectacularly. Typically, like you're logged out. Chances are because that secret isn't everything. There's probably other configuration files on the system somewhere, right? So step 5 is figure out how to do this. So let me show you. If you have Xcode and developer tools on your Mac, you have this really powerful thing called instruments. So if you go to instruments and you're like, give me a new instruments project, you can say, I want to monitor all file activity for something. And you can give it Slack app. And then you can start it and you can click record and it will launch Slack open and it will trace all the files that it touches. So then I can scroll through here, kind of looking for like, hey, like where does Slack like put its stuff? In scrolling through here, I find this guy, right? Under my user, under library, under containers, under com.tinyspec.slack.mac.app, data, library, application, support, Slack, and then there's a bunch of stuff in there. So, like, okay, maybe these files are what I need. So I'm going to just take all of these files. I could by trial and error or by reverse engineering Slack figure out exactly which file has that one key important piece of information. In trying to do that, I was able to get like all of the various like Slack channels I was in like pulled up, but all of them were asking me to auth again. So there's something else that I haven't quite found yet. But it doesn't really matter because we have everything we need. We can just take this whole thing. So wait, let me try and how long is this talk? How much time do I have? Do I have 20 minutes still? 15, 20? Okay, cool. So let's demo this. I have another user account on this system, and I am going to then like let me just show you, I suppose. Let's see if this works. So I have other not FuzzyNop user. And over here I am, I have Slack, I'm logged in, I'm logged into the nothing to see here space as not fuzzy. My life is great, I can use Slack, it's amazing, okay? So I'm gonna get out of Slack just to avoid complications. I don't think it matters actually. You can move all these files and change them in the next time Slack is loaded, but it could get a little messy if things are updating and pushing down. So in here I have, I know, right? Do you suddenly like never trust your computer anymore? So in here, I have some values for my tokens that keep me logged into Slack. I have already copied out my values for this other thing, which I probably shouldn't be putting up on the screen right now, now that I think of that. Luckily, it's real small, huh? So I'm going to change it, and I'm going to post these values from my Slack login. So now this guy's in there. I'm going to click Save Changes. Now the keychain has been updated for this user. It's going to be easier for me if I go back over here. Did I prepare for this? I think I did. I don't know why this is happening. Okay, so just to be safe, I am going to completely blow away all of the files that are in that Slack folder for that other user by just removing it. And then I'm going to copy these. Now, you'd be doing this on a remote system, not like from one user to another, but like for demo purposes, I think this works. I'm going to copy those files over. And then also, they're all still owned by regular FuzzyNop users, so I'm going to update the permissions to be the correct user over there. So now that those files are in place, they've been moved over, the keychain's been updated. I'm going to pop back over to this other guy. and I'm going to launch Slack, it's going to ask me this. So this would be happening on a system that you control, so the user's never going to see anything change or be weird because of this. Good to know. I'm going to cross my fingers. Oh, damn, guys. So, yep, here we are. This is my personal Slack that this other not fuzzy is suddenly logged into. Game over. So now I have a really great place to fish people from, to monitor what the blue team's doing, to read messages, to look at files that have been shared previously in Slack. And if, say, maybe like they're doing Slack good, and they like when you go to log in to Slack, it's like 2FA and everything through a single sign-on portal. This technique would effectively bypass that, and you could be logged into people's Slack instances from some other system. Not bad, right? So this general approach isn't like a Slack specific thing, right? Like I originally made this this demo for a class and used HipChat, but like HipChat's sort of like gone away. But like anything on the system that you notice, like, whoa, I stay logged in through reboots, something like this is probably going to be possible because there is stuff in disk and there's probably secrets in the keychain that allow you to recreate that application state and pull it up somewhere else. So this also works for like Firefox, right? All of your Firefox like sessions, you know how when you close Firefox out or like something bad happens and you start it up again and it's like, whoa, like do you want to restore all your tabs? And you're like, yes, please, and you get logged back into Gmail and a ton of other places. You can basically just take like that entire, there's nothing in the keychain in this case, you take that entire Firefox folder, you throw it onto another VM, you open up Firefox, you click restore, you get logged into everything. So this general approach will scale and work with lots and lots and lots of things. So steps here in review, transfer secrets from the keychain, find those config files on disk, recreate the state somewhere else by moving them to another machine, profit. So one potential like mitigation to this, maybe they are like really paying attention to where you're logged in from, and if you get logged in from somewhere else, that's like a no-no and they log you out. But remember, you probably have shell on that person's computer, so just set up a reverse tunnel with like a SOCKS 5 proxy and push the traffic through their system. That way it's still coming from the same place and you'd be able to get around that too. Okay, one last thing. This is the easiest, most stupid 2FA bypass that has been working for me great lately, and just a few things about it. So I originally discovered this not because I was like, I'm going to do some research and find some lead hacks on how to bypass 2FA, but because while on an operation, while looting their bash history and seeing the PS output of them SSHing somewhere, I just like copied the SSH command, like typed it in, got logged into like a bastion with no prompt for a password, no prompt for 2FA. So like, well, why did that happen? That's really strange. That's not supposed to happen. It turns out that if you Google control master for SSH, it's a setting that everyone loves to use so that you can multiplex your SSH connection. So once you log in once, you can go do things like STP and SSH, open up new terminals without having to log in, without having to hit 2FA again. So if you put this in someone's config file for them, and you wait for them to log into a bastion, you can then log into the bastion also and follow them. And you can keep doing that through production environments and effectively bypass 2FA measures there. So perhaps you're like, what if they're like, you know, maybe a company's like, we're going to stop this from happening by like mandating SSH configs so people can't do this. Well, then you would just maybe go into their bash profile and create an alias for SSH to add these commands onto the command line, so anytime they type SSH, it gets done anyways too, right? So probably multiple ways to do this. A few important things. If you put it in auto mode, you can scope it to host, so maybe you don't want it to happen to every single thing. I mean, why not though? Control master auto, it's going to take care of everything and do it automatically for you. The control path is where it's going to store a socket file. You can put this anywhere you want. If you use things like %h or %r, %p, that will fill out things like the username, the host, the port in the file name for you, so that you can have like multiple ones on disk. So with this, the original config I found just had these first two things, right? Which kind of sucks because if I follow someone in and they close their master connection, the first one, it boots me out too. But if I say control persist, and control persist could take a time, like a week, a month, or something like that. But if you just say yes, it persists indefinitely until the socket times out or breaks or something like that. So then, if they quit, it still lets you stay in, and you can keep using that socket forever. So basically, once they make a connection to any host at all, you'll be able to go there without any passwords at all. One more caveat discovered yesterday by the class I was teaching. We noticed that when you log out of your main session, there is one thing that you see differently. You suddenly see shared connection to whatever host closed, which is like a different message than you would normally see when you log out. So the way to get rid of that is to add log level quiet, and then they don't see that at all. So now the solution is good. And that's the end. Are there any questions?
Why is that on the slide?
To seed the first question.
Success.
No? Way in the back? Yeah, I would say the techniques are transferable, but copying and pasting the commands definitely won't work. You'll have to find similar things, right? Yep. Yeah. All right, I'm going to get off this stage. I'm sick of hearing that sound. Bye. Thank you.